Hello and welcome to another one of D's ADD videos. Today we're going to be discussing substitution and elimination reactions. When people are looking at substitution and elimination reactions, they focus so much on the details they get lost and they fail to see the big picture. I feel like if you take a step back and see the big picture, the individual problems become a lot easier. The substitution reaction, what we're going to have is an electron-rich species. Actually, in both we're going to have electron-rich species, but it depends what they do. If they attack an electron-poor carbon, an electrophile, and replaces a leaving group, then it's a nucleophile. So here we have carbon and a halogen. This is an alkyl halide. We discussed how to make these with free radicals in the previous chapter. Now, these guys are going to be attracted, these electrons, to this carbon, because this carbon is bonded to a halogen. And the halogen has a high electronegativity, so it withdraws the electrons, making this partially negative. This is partially positive. You get a dipole. And this is electrophilic, likes electrons. Nucleophiles got electrons. So it comes and binds. And either in a two-step process or a one-step process, we end up replacing that halogen leaving group with a nucleophile. What makes a good leaving group? It has to be electron withdrawing. It has to be stable when it leaves as an ion. Elimination reaction is a little different. Our electron-rich compound could be the same exact compound as we had over here, okay? But instead of attacking this electron-poor carbon, what's going to happen is we're going to attack a hydrogen adjacent to it, all right? E2, it has to be anticoplanar. We'll discuss that later, but E1 can be this one here. And we end up basically having the base come in, attack the hydrogen, leave the electrons behind, and form a double bond. They fill the p orbital and form a pi bond. You get an alkene, all right? You can further make distinctions between substitution and elimination depending on one or two. So group one, for instance, you're going to be looking for weak to moderate attackers, alcohols, okay? It's a two-step reaction. First step is we're going to form what's called a carbocation. If you remember discussing these are the ones that have the MTP orbital that are sp3 hybridized and basically have a plus charge, 3-2-1 stability. Then we're going to either have elimination if we attack the hydrogen with our electron-rich species, or if it's attacking the electrophilic carbon here, then it's a nucleophile and it's a substitution reaction. So the one reactions are solvolysis reactions. What does it mean to be a solvolysis reaction? It means that the solvent is what's doing all of the work. And we place a solute in the solvent, right? And the solute usually is far smaller in concentration than the solvent. And the concentration is so drastic that it's irrelevant. The solvent's concentration is irrelevant. Just the solute being the alkyl halide. So the kinetics, as a result, is just based on the concentration of the alkyl halide we're given. Hence the one reactions, E1, SN1. We have a strong attacker, like an alkoxide ion. All right, you might see an alcohol below it, but if you see this with an Na or something like that, then we know that it's a two reaction. And these are one-step reactions, unlike the one reactions. A little confusion. The one reactions are two-step. The two reactions are one-step. Here we're going to form a transition state. So in the two reactions, the moment this thing binds here, this starts breaking. You form a transition state, and the moment that bond's formed, this one's broken. It's a one-step reaction, also known as a concerted reaction. Then we get our elimination or substitution. This is not a solvolysis reaction. The two reactions aren't. So you'll have the nucleophile or base, whatever it is, and the alkyl halide. But you'll also have a solvent. All right, so the nucleophile base concentration and the electrophile concentrations are going to be important.
So the kinetics of this is bimolecular to, depending on whether it's substitution, the nucleophile and the alkyl halide, or if it's elimination, the base and the alkyl halide.
Solvents are going to play an important role. All right, make sure you check out the handout for which solvents are best. Check out the example videos in which I will go into more detail about solvents, and also I will make a concept video for each one of the reactions, so check those out. But this is the big picture. I want to make sure that everybody understood what to look for. There are things like heat that can favor elimination reactions. Silver nitrate can push things towards certain directions. So make sure you know the details. Again, practice, 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 and you'll feel right at home with these reactions. Otherwise, you might feel a little lost. Thanks for watching. Have a great day.